Okay, we're looking at problem 3, modeling exponential decay. So if we go back to the page before, decay, this time my base is going to be between 0 and 1. So it needs to be some type of decimal or fraction number. And it's going to be a decay because I'm going to be subtracting from 100. So it's 1 minus the percent rate. All right, so it's the decay factor. So let's look at the problem. Okay, it says the kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude, the pressure decreases about 11.5%. Notice this in decreases. What is the approximate pressure at an altitude of 3,000 meters? So we're going to use the same formula. X is the altitude in meters. Y is the atmospheric pressure, and let's do it in kilopascals, of course. The altitude is in thousands of meters, so then we will have to have like 1,000 exponent there. A is the initial pressure, and we know that the initial pressure is 101. And B is the decay factor, which is 1 minus my percent, and I'm going to change it by moving my decimal place over 2 places, so I get 0.115. 1 minus 0.115 is 0.885. And so my equation is y equals 101 for my initial amount times 0.885 to the x power. It says use the equation to estimate the pressure at an altitude of 3,000 meters. And again, we have this x is in thousands, so I don't have to use 3,000. I can just use 3. And so when I do that, I get 70. So after I evaluate, I get 70, and I round it to the nearest pascal. So it says the pressure at an altitude of 3,000 meters is about 70 kilopascals. All right, so let's look at the guided number 3 now. So guided 3 says, what is the atmospheric pressure at an altitude of 5,000 meters? So I've written it here on my whiteboard. Here's the formula. And for x, instead of putting 3, I'm going to put 5 this time, excuse me. So I'm going to put it in my calculator. So that's 0.885 raised to the 5th power. So this is what I get. I'm going to multiply that by 101. And I get 54.8. And it makes sense because we want it to decrease. It's supposed to be decreasing. So 54.83 kilopascals. All right. So then it says, why do you subtract the percent decrease from 1 to find the decay factor? Well, it's decaying, so I'm not increasing my percentage by 100. I'm decreasing it, so that's why I need to subtract. I hope this helps.